Dear friends, in this video, we look at another problem which we call problem number 2 on pricing analytics. Let's see the problem. Suppose it costs $250 to produce a video game console. A price between $200 and $400 is under consideration. Estimated demand for the game console is shown in the following table. What price should you charge for game console? Problem adapted from Wayne Winston Marketing Analytics for discussion. In this problem, we have got three distinct positions for demand corresponding to the prices $200, $300, and $400. So what we do is we plot and we do the tracing of the curve and fit an equation which is appropriate and which we easily get it in Excel. So let me just show you the graph here. Behavior of the demand curve for different prices that are charged in the range of 200 to 400, and given the data which we have, the curve behaves like a quadratic curve, polynomial of degree 2, y equal to 0.6x squared minus 550x plus 1,36,000, that which is the constant. So this is the equation for the demand. Let's now proceed with the solution. The demand curve is polynomial degree 2 and it's given by 0.6x squared minus 550x plus 1,36,000, which is the constant. Now, profit is equal to x minus 250 into 0.6x squared minus 550x plus 1,36,000. Why? Because if price is x and the cost of a console is $250, we subtract. You can look at the problem which is given and you will notice that. Let me just go back to that and show you that. So it costs $250, okay? So that's what I put here. Upon simplification, profit becomes equal to, because contribution is x minus 250 multiplied by the demand. This is the contribution or profit per unit multiplied by the demand. So this equation upon opening the two brackets is equal to this, and upon simplification, it's equal to 0.6x cubed minus 700x squared plus 273,500x minus 34,000,000. That means 6 zeros after 34. This is the simplification. Now this will have to be maximize P, subject to the constraint. The price will have to be in the range between 200 and 400. So x greater than or equal to 200 and x less than or equal to 400. These two constraints are there. Upon solving, optimal solution is x is equal to 400. So charge a price of $400. Demand is equal to 12,000 units upon simplification, and then profit is equal to $18 lakh. Okay, this is the picture. Actually, I can model it in the next video perhaps to show you how to do it in Excel solver optimization using nonlinear optimization. Okay, now let's look at the graph now. The final graph, behavior of demand curve with profit for different prices. As you can see, price on the x-axis, demand on the y-axis. And you can see this graph beautifully. When x is 200, is a loss. The demand is 50,000, but you are getting a loss. 200 minus 250. Multiply by that, multiplied by the demand 50,000, you'll get this number, which is a loss. When the price is 300, the demand is 25,000, multiplied by the contribution of the profit 300 minus 250, you'll get $12,50,000. And when the price is 400, the demand is only 12,000, but the contribution of profit is 400 minus 250, which is 150. Multiply this by 12,000 units, you get $18 lakh, which is the optimal solution. Signed, sealed, and delivered. The second problem, ladies and gentlemen. For your ready recapitulation, go back to the previous slide and see demand is 12,000 units, profit is $18,000, and you have to charge the price $400. The problem is solved. Thank you very much. We will see you in another video soon.